Welcome to the session on mathematical expectation. Let x be a random variable and phi of x be a function of x. Then the mathematical expectation of phi of x is defined as E of phi of x is equal to summation over x phi of x into f of x, where f of x is the probability mass function. Here f of x is the PMF, that is probability mass function of the discrete random variable capital X. And in continuous case, the definition is integral phi of x into f of x dx. The limit of integration is minus infinity to plus infinity. Here x is continuous random variable and f of x is the probability density function PDF. This is the definition of expectation. Now, if we take phi of x as the identity function, then this expectation becomes E of x, which is known as the arithmetic mean. That is the definition of arithmetic mean in terms of expectation is E of x. It is denoted as mu. Now, if we take the function phi of x as if phi of x is equal to x minus mu, that is mu is the expectation of x whole square. If we take the function phi as x minus mu the whole square, then the expectation of x minus mu the whole square is known as the variance of x. That is variance of x is denoted by sigma. Notation is sigma or v of x. That is variance of x is expectation of x minus mu the whole square. The positive square root of variance of x is known as the standard deviation. Standard deviation. Is the positive root of variance of x. Now, if we take the function phi of x as modulus of x minus a, where a is a constant, then the expectation of this mod x minus a is known as the mean deviation about a. This is the mean deviation about the constant a. If we take a as mu, that is if we take the value of a as the value of expectation of x, then the expectation will become E of mod x minus mu, which is known as mean deviation about the mean. These are the definitions based on the expectation, that is the arithmetic mean is E of x, variance of x is expectation of x minus mu the whole square, mean deviation about a constant A is expectation of mod x minus A, and mean deviation about mean is expectation of mod x minus mu. Now, let us see some properties of expectation. If phi of x is equal to a constant function c, where c is a constant, then expectation of phi of x is equal to expectation of c. By definition, this is equal to summation over all x c into f of x, where f of x is the PMF of a discrete random variable capital X. This is equal to c into sigma over all x f of x. Since f of x is a probability mass function, by the property of probability mass function, we can write this summation f of x as 1. Value of this summation is 1. Therefore, this is equal to c into 1, that is c. That is, expectation of a constant is the constant itself. Now, if C1 and C2 are two constants and phi 1 of x and phi 2 of x are two functions of the random variable capital X, then expectation of C1 into phi 1 of x plus C2 into phi 2 of x is equal to C1 into expectation of phi 1 x plus C2 into expectation of phi 2 x. We can prove this result by using the basic definition of expectation. That is, the left hand side is expectation of C1 into phi 1 of x plus C2 into phi 2 of x, which is equal to summation C1 into phi 1 of x plus C2 into phi 2 of x into f of x dx, into f of x, where f of x is the probability mass function of the discrete random variable capital X. Here the summation over all values of x. This is equal to summation over all values of x C1 phi 1 of x into f of x. We just open this square bracket, we get C1 into phi 1 of x into f of x plus C2 into phi 2 of x f of x. Now, we split this sigma into two sums, this sum into 2, which is equal to summation over all x C1 into phi 1 of x into f of x plus sigma or summation over all x C2 into phi 2 of x f of x. This is equal to, here summation over x, therefore, the constant C1 can be taken outside, which is equal to C1 into summation over all x phi 1 of x into f of x plus C 2 into summation over all x phi 2 of x into f of x. Here C 2 also a constant, therefore, the constant C 2 can be taken outside of this summation. This is equal to C 1 into, by definition of expectation, this is expectation of phi 1 of x. Plus C 2 into, this is expectation of the function phi 2 of x. By definition of expectation, this is C 2 into E of phi 2 of x, expectation of phi 2 of x. That is expectation of a combination C 1 phi 1 x plus C 2 phi 2 of x is equal to C 1 into expectation of phi 1 of x plus C 2 into expectation of phi 2 of x. This property is known as the linearity property of expectation. This property is also true for the continuous case also, because in continuous case we just use the integrals instead of all these sigmas. Then by the property of integration, we can take the constants outside of the integration, and we can split a sum of an integral of a sum into two integrals. Therefore, all these properties are held in the continuous case also. Now, by the definition of variance, we have variance of x is expectation of x minus mu the whole square, where mu equal to expectation of x. This is equal to expectation of, we expand x minus mu the whole square, we get x square minus 2 x into mu plus mu square. This is equal to expectation of x square. By the linearity property of expectation, we can split these terms, that is equal to expectation of x square minus, here 2 is a constant, also mu means expectation of x, which is also a constant. Therefore, we can take outside 2 into mu, that is minus 2 mu into expectation of x, plus here mu square is a constant, therefore, expectation of mu square. Expectation of mu square is mu square itself. This is equal to expectation of x square minus 2 into mu is expectation of x into here expectation of x plus mu square means e of x the whole square. This is equal to e of x square minus 2 times expectation of x into expectation of x is expectation of x the whole square plus expectation of x the whole square. This is equal to e of x square minus 2 times e of x whole square plus 1 e of x whole square is minus 1 e of x whole square. that is variance of x equal to expectation of x square minus expectation of x the whole square. We can deduce this result from the definition of variance of x. This result may be used in many problems regarding the variance of x. Here E of x square means by definition of expectation summation x square f of x if x is discrete and f of x is the probability mass function, and this is equal to integral x square f of x dx, where f of x is the probability density function of a continuous random variable capital X. Now, by the definition of expectation, we have expectation of a x plus b is equal to summation a x plus b into f of x. This is equal to summation a x into f of x plus b into f of x, which is equal to, we split this sum into 2, that is sigma a x into f of x plus summation b into f of x. Here summation with respect to x, therefore, the constant a is a constant which can be taken outside, a into summation x into f of x plus here b is a constant, therefore, b can be taken outside, this term is b into sigma f of x, which is equal to a into, by definition of expectation, this is E of x, expectation of x plus b into, here f of x is a probability mass function of a discrete random variable, then summation f of x is 1. Therefore, variance expectation of a x plus b is equal to a into expectation of x plus b. This is a property of expectation. Now, similarly, variance of x plus b is equal to, in the continuous case also we can prove this result. Now, variance of x plus b is equal to, we have variance of x is equal to, we deduced this result, variance of x equal to expectation of x square minus expectation of x the whole square. We use this definition, we can write this as expectation of, here instead of x, ax plus b, therefore, expectation of ax plus b whole square minus e of x the whole square, that is expectation of ax plus b the whole square. This is equal to expectation of, here we just expand this, a square x square plus 2ax into b plus b square minus, here a into e of x, we can use the linearity property, that is a into e of x plus b the whole square. This is equal to, here a square is constant, therefore, a square can be taken outside, a square into expectation of x square 2ab AB is a constant into expectation of x plus b square, expectation of b square, b is a constant, therefore expectation of b square is b square itself, minus here a into e of x plus b the whole square is a square into e of x the square plus 2ab into e of x plus b square. Just expand this a into e of x plus b the whole square. This is equal to a square into e of x square plus 2ab into e of x plus b square minus a square into e of x whole square minus 2ab into e of x minus b square. That is equal to here 2ab into e of x minus 2ab into e of x cancelled, b square and minus b square cancelled. The remaining terms are a square into a square e of x square minus a square e of x the whole square. Therefore, a square is common, a square into expectation of x square minus expectation of x the whole square. This is equal to a square into, by definition, e of x square minus e of x the whole square is variance of x, a square into variance of x. That is variance of ax plus b is equal to a square into variance of x. If here negative, if that is variance of ax minus b also is equal to a square into variance of x. This is a property in the variance. Now, let us practice an exercise. Obtain the arithmetic mean and variance of x from the following data. The data is we are given values of x and corresponding probabilities. X values are 0, 1, 2, 3, 4 and 5, and the y values are, that is the probabilities, not y, the probabilities f of x are 1 by 6, 5 by 18, 4 by 18, 3 by 18, 2 by 18 and 1 by 18. We have to find the arithmetic mean of x and variance of x. We are given the probability function as this, that is this is a discrete probability function. Therefore, by the definition, mean of x is equal to expectation of x, that is summation x into f of x over all x. The first value of x is 0, 0 into the corresponding probabilities f of x is 1 by 6 plus next is 1 into corresponding probabilities 5 by 18 plus 2 into 4 by 18 plus 3 into 3 by 18 plus 4 into 2 by 18 plus 5 into 1 by 18. Just multiply the x values and the corresponding values and add all these values. On simplification, we get value of this as 35 divided by 18. This is the mean of x. Now, variance of x, by definition of variance, we have v of x is equal to e of x square minus e of x the whole square. Here e of x is already obtained 35 by 18. Therefore, we have to find only e of x square. By definition of expectation, e of x square is equal to summation x square into f of x overall x, that is equal to, first is 0 square into 1 by 6, which is 0, plus 1 square into 5 by 18 plus 2 square into 4 by 18 plus 3 square into 3 by 18 plus 4 square into 2 by 18 plus 5 square into 1 by 18. Just squaring all the x values, and we multiply the respective probabilities, then we add to obtain e of x square. On simplification, this is equal to (35) divided by 6. Therefore, by using the definition of this definition of variance, we get variance of x is equal to e of x square is the 35 divided by 6 minus e of x whole square. E of x is the mean of x, that is 35 divided by 18, 35 divided by 18 the whole square, which is equal to, on simplification, we get 665 divided by 324, which is the variance of the corresponding probability function. Let me conclude this session. In this session, we discussed the expectation, that is the mathematical expectation, and we derived some properties of expectation, and we solved one problem. Thank you for watching this class. Have a nice day.